Hello, my dear students. This is Dr. M. Vijaysankar, Assistant Professor, Department of Statistics, St.Joseph College of Autonomous, Cuddalore. The last video, we have discussed about Unit-V large sample test. The topic is chi-square test. In this video, we are going to discuss about the same topic with another different types of problem. The assumptions. Already we have discussed about the assumptions. The observations record and used are collected on random basis. The sample observations should be independent. The total number of observations, that is total frequency, must be more than 50. And the fourth one is, in order to maintain the nature continuous distributions of the chi-square, we assume that no theoretical self frequency is less than 5. In this topic, we have using the problem less than 5 value. So we are using this assumption and solve that problem. If it is so happens, we pull it with the preceding or succeeding value. Suppose if the value is less than 5, we are adding the value preceding or succeeding one. Okay, the fifth one is the constraints must be linear. The constraint which involves linear equation in the self frequency of the contingency table. The equation of the containing no square or higher power of the frequencies are known as linear constraints. This is problem 2. Two researchers adopted different sampling techniques while they investigating the students to find the number of the students falling in the different intelligence level. The results are as follows. Here, the researchers and the intelligence levels are given in this table. Using this data, we are going to calculate chi-square test. The given data, could you say that the sampling techniques adopted by two research are significantly or differ? Using this data, we are going to test there is any significant difference between research and intelligence levels. First of all, in the solutions, first of all, we are going to calculate the row total and column total. The row total is the researchers X and Y, and the column total is the intelligence level of average good genius. So row total is 200, 100. The grand total is 300. The column total is average is 126. The greater than average is 126. Average is 93. Good is 69, and genius is 12. Now, we fix the null hypothesis and alternate hypothesis for the given problem. The null hypothesis is that two attributes age and TV channels are independent. The alternate hypothesis is the two attributes age and TV channels are not independent. Next, we are going to using test statistic formula. The chi-square equal to summation of O minus E divided by E square. Using this formula, we are going to find the expected frequency values. Here, the given values of expected frequency values is 86. Observed frequency values is 86, 60, 44, 10, 40, 33, 25. Using this observed frequency value, we are going to find the expected frequency values. Already we know that the expected frequency formula, the row total into row total into column total divided by grand total. Using the row total is 200 and the column total is 126. The grand total is 300 divided by 300. We get 84. Likewise, we calculate one by one. Finally, we reach the observed frequency values is 86 chi-square table. Observed frequency values is 86, 60, 44, 100, 10, 40, 33, 25, 2. Here, the last two cells, see the last two cells, the last value is 2. So, it's less than 5. So, the value should be in adding with the preceding one. So, 25 plus 2, we get 27. So, that only we are using the another observed frequency values and another expected frequency values in this table. Okay, finally we are going to solve this, subtract this value one by one and squaring and divided by expected frequency value. Here the total number of observations is 1, 2, 3, 4, 5, 6, 7, 8. The 8 observations is converted into 7 observations because the last value is less than 5 in the observed frequency values as well as the expected frequency values. So that only the 8 observations is converted into 7 observations. Then next we are going to calculate the observed frequency value minus E, then squaring that value and divided by E. So subtract and square divided by E. We get 0.0, the last column. The 0.0476 and 0.066, 0.08, 0.5 and 0.09, 0.12 and 0. Finally adding this value 0.9233. This is called as the chi-square value, calculated value. Using this calculated value and comparing with the table value. Here the table value can be obtained from chi-square table R minus 1 into C minus 1. R is the row total and C minus 1 is the grand total and minus 1 is the less than 5 values. 1 value is available in the table. So that subtract minus 1. So 2 minus 1 into 4 minus 1 minus 1, we get finally 2 degrees of freedom. And we are using 5% level of significance in the chi-square test. The table value is 5.911. Comparing, finally we reach to the conclusion. The calculated chi-square value is 0.9233 and the chi-square table value is 5.911. So the calculated value is less than table value. So we accepted the H naught. Hence there is no significant difference between intelligent level and researchers levels. Thank you for watching this video. If you have any queries, we will discuss in the classroom. Thank you.